So, greetings, students. Welcome to today's lecture, and today we'll be seeing about the continuation of the problems with respect to your per unit system. So, in the last class, I have solved two problems with respect to your per unit. Okay, how you have to find the per unit if they are giving the actual impedance in terms of ohms. Otherwise, if they are giving in terms of percentage, what kind of formula we have to use? I have distinctly shown with two separate problems. And apart from that, I have also given another one problem and asked you to solve it. Okay, so have anybody solved the problem? Anybody?
Yes, sir, but having one doubt, sir.
This is the third problem. Anybody has tried it? I will be solving it again, but have anybody
Sir,
tried it?
I tried, sir.
Okay. So, what kind of answer you got? Can you just tell me out?
Just a minute, sir.
Okay, fine.
Sir, ZG1 I got J0.6862 PU, sir.
Fine. Okay, it's good. Right.
Uh, I have a doubt only in ZM1, sir. ZM1 I got J0.256 PU. It's right or wrong, sir?
0.256 pu. Yeah, it's right.
Right, sir, but when I solved using calculator, I got 1.
Sir, 1.0256 is the
Yeah,
answer,
one.
sir.
Yeah. Yeah, okay, we'll be just seeing it. I think it is 1.0 only. It will be coming out.
Yes,
Okay,
sir.
we'll be seeing. We'll be solving step by step.
Okay, sir.
Okay, fine. So for those who didn't try the problem, just you keep an eye on this problem because it's very simple. You'll be applying the same formula in a 4 different equipments. Okay, so we'll be moving on. So in the last class, I was not able to post the problem as a PDF because I used whiteboard, Microsoft Whiteboard. But now I'm going to use a Jamboard. Okay, in Jamboard I will be able to convert this into a PDF, and at the end of each class I will be posting the recorded session as well as this PDF also. Okay, so it will be very easy for your reference. So now we will be coming to the point, and here they have given two generators. Okay, two generators, and each of them rated with 10 MVA, 15 MVA, and with respect to the motors, one is rated at 8 MVA and another one is at rated 12 MVA. And the key point over here for the single line diagram that you have to draw is they are connected in parallel. So this is the key point. So using this key point, you can draw the single line diagram. So in most of the cases, they will be giving the diagram itself, but in some other cases, it is you who have to draw the diagram. Okay, so I'll be drawing the single line diagram. So this you can take it as a G1, and this you can take it as your bus bar 1. Okay, so over here, as per the question, your G1 and G2 are in parallel and they are connected to the same bus bar. So this is a bus bar 1, they are connected in the same. After this, drawing this equipment, you have to write the rating below. Okay, it is rated for 13.2 kV and the for 15 MVA. Okay, 13.2 kV. First generator is rated for 10 MVA. Okay, first is rated for 10 MVA and the second is rated for 15 MVA. So this is at the source side, and coming to the load side, you can take it as bus bar 2. Okay, you can take it as bus bar 2, and over here, two motors will be connected. M1. Okay, it is off. You can take it as 8 MVA, with a voltage rating of 12.5 kV. Okay, 12.5 kV, and over here they have also given your reactance. So here for the generator, the percentage of reactance is 0.15 for both the generators. Okay, and for the motor it is 0.2. Okay, and now we have to get with the second, which is M2. Okay, your M2 is rated for 12 MVA, 12 MVA, and it is the voltage is 12.5 kV, and again it is for 0.2. Okay, and you have to connect your source side with your load side. Particularly, they have asked to find only the reactance, that is per unit value for this G1, G2, M1, M2. They didn't ask to find for the transmission line. Okay, so our primary objective will be related to these four equipments. Okay, so this is what with the diagram, and now we will be moving to the problem. Also, they have in the question what they have given is, so what they have given is, they have given the common base MVA. They have asked to take the common base MVA value as, they asked to take the common base MVA value as 50 MVA. Okay, and common base voltage is 13.8 kV. So it is also given in the question. So these two contributes to your new value. Okay, these two contributes to your new value. So you can just write as new, and over here also you can write it as new. Okay, so you can go to the solution. First one is you can take for G1. G1, okay, you can just write the formula. Z per unit new will be equal to Z per unit given, okay, into MA new by VA given. Okay, this is what with respect to the power component. Coming to the voltage component, it will be the reverse. Okay, first the will be base kV given divided by base kV new, and it will be followed by the square. Okay, it's a square. Okay, so now you have to apply the formula, that is the Z per unit given for generator 1. So this will be contributing to your 0.15 value. Okay, this is the value. This value you have to take will be 0.15. 0.15 into base MVA new is this value, will be 50 divided by base MVA given. So base MVA given is this value, that will be 10. Okay, will be 10 into base kV given. So base kV given is 13.2 kV, 13.2 kV divided by base kV new is this value, 13.8 kV, the whole square. So you will be getting the value around, as he said, it will be for G1, it will be Z per unit mu will be equal to, so you can just use a calculator and you can just do it. Okay, if you hang calculator, you just try this simplification. I'll be giving around 1 minute. I'll be giving, afterwards we'll be moving on. So okay, you'll be getting the value around 0.6862 J. Okay, so this is the value you'll be getting, and if you are solving this, this is the value you'll be getting. And coming to the generator 2. Okay, and the same formula is applicable. Z per unit nu will be equal to Z per unit given into base MVA nu divided by base MVA given, okay, into base KV given divided by base KV nu, the whole square. Okay, upon applying, what you'll be getting for G2, the ZPU is the same, 0.15 into 15 by 15, okay, into the voltage rating will be 13.2 by 13.8, the whole square. Okay, and for this we just try to solve in your calculator. So what is the value? What you'll be getting is around 0.4575 J. Okay, it will be 0.4575 J. So next we will be moving to the motor 1. For motor 1, again the same formula applicable. Z per unit nu will be equal to Z per unit given into base MVA nu by base MVA given, so into base KV given by base KV nu, the whole square. And you will be getting, after substituting, you will have to put 0.2 into 50 by 8 into 12.5 by 13.8, the whole square. So try to solve this equation. And you will be getting the value as for motor 2 the value will be 1.0256 J. Okay, so now we'll be moving to the motor 2. So for a motor 2, again the same formula, Z per unit nu will be equal to Z per unit given into base MVA nu by base MVA given into base KV given by base KV nu. So if you're referring some textbooks, these notations will be varying. Okay, but if you're having this kind of rotation, it will be easy for you to remember it. Okay, so on applying for the motor, it is 0.2 into 50 by 12 into 12.5 by 13.8 the whole square. So we'll be getting the value to be so I'll be getting around 0.683 J. Okay, so this is what with respect to the problem. And after this, what you have to do is they have asked to draw the reactance diagram. Okay, as I said, what is the purpose and need for this single line diagram, impedance diagram, and the reactance diagram is that it is easier representation of your entire power system. Okay, you have to know why you are solving this problem. What is the necessity for solving this problem? Okay, so the necessity lies in making the complex network to be a simple network. Okay, so how it becomes means we might have already seen in some previous classes the equivalency for your generator and your motor. Based upon that, the diagram goes like this. So this will be your G1, and so this will be J 0.6861. Okay, and followed by this, it will be your generator 2 is in parallel, so it will be generator 2 G2. Okay, and this will be J 0.4575. Okay, so after this, for your motor, so your motor will be on the load side, but it is in parallel. Okay, it will be M1, and this will be J 1.026 followed by motor 2 M2. It will be J 0.6837. So we have drawn the equivalencies. Now we have to just connect it. Okay, and this represents your reactance diagram. Okay, I hope you can understand up to this simple problem. The same formula will be applying for 3 equipments, electrical equipments, and finally we'll be drawing the reactance diagram for it. Okay, and now we'll be moving to the next problem. So next problem is somewhat complex problem. So we'll be dealing with some complex problem hereafter. Before getting into such kind of problem, so you just take a note. Okay, just take a note for common. Okay, so this note is applicable for all the problems. Okay, all the complex problems that we are going to solve. Okay, so you take it comprises of nearly 3 points. Okay, sorry, 3 to 4 points I think. So you just take down. The first point is that the common base MVA is same throughout the sample power system network. So what here they are implying is that so the common base value that you are selecting will be entirely the same throughout the power system. That is, the common value based upon which you are going to normalize, or based upon the which value you are taking as a reference, will be the same throughout the entire power system. Okay, while solving the problem, you'll be getting the clear idea. But in such the previous problem, what they have did was they have given the common base value. Okay, but while dealing with some complex problems, the thing is that it is you who have to select the base quantity, or sometimes in the question itself they'll be giving. So second point is the revised base kV, that is voltage nu, has to be calculated whenever the transformer is present in the network. So in case of the transformers, we will be having primary as well as secondary. In most of the cases, we won't be having same voltage rating in your transformer in the power system. So what you'll be doing is that you'll be either having a step up transformer or a step down transformer. So based upon that, you have to adjust the voltage rating, even your impedance diagram. Okay, so while solving the problem, we'll be getting into the idea. Okay, so how you can find this revised base value? Okay, how it is possible to find this revised base value is using a formula. So the revised base voltage kV nu will be equal to existing base kV nu into your nothing but it is your voltage transformer ratio into your transformer ratio. So these points you have to keep in your mind. Okay, these 3 points you have to keep in your mind. And also for the transmission line also it varies. That is, this might be your transformer. Okay, this might be your transformer. Okay, so you'll be jumping from your primary to your secondary side. While jumping from primary to secondary side, you have to find the revised base value of voltage for your secondary of the transformer, as well as the secondary of the transmission line also you have to find. Okay, so I'll be saying how to find for that, but you have to keep this in mind. Okay, whenever you're jumping from your primary to secondary or from your secondary to primary, You have to use this kind of formula. Okay, we'll be moving to the problem, so it will be very easy for you to understand. So this contributes to your fourth problem. So 100 MVA, 33 kV, 3-phase generator has a reactance of 15 percentage. Okay, the generator has a the generator is connected to motors. More than one motors are used through transmission line and transformers. Okay, and the motor has rated input of 30 MVA, 20 MVA and 50 MVA. So from this, what you can understand, nearly 3 motors are connected as a load. So the voltage rating is the same. It is at 30 kV with 20% reactance. Okay, the 3-phase transformers are rated as follows. It is 110 MVA is the rating, 32 bar 110 kV. Okay, and they have given the configuration as delta 2 star. Okay, so with leakage reactance of 8%. Okay, the transmission line has a reactance of 50 ohm. So here they have given the actual impedance value. I given the actual impedance value only for your transmission line. You have to be clear with it. Okay, don't get confused. They have given the actual impedance value only for your transmission line. Okay, selecting the generator rating as base quantities. They have given the thing what you have to select for the base quantities. Okay, determine the base quantities in other parts of the system. And also evaluate the per unit values. So here in this problem, it is clear that they didn't give you that figure. Okay, they didn't give you the figure, but they have given very
Sir,
clearly
can
that.
you show this page, sir?
Yeah, yeah.
1 minute, sir.
So okay, I'll be giving some time. You just go through the question. Okay, so I'll be giving some time. You just go through the question. So okay, we'll be just moving on. So here, what they have given is that they have given the rating. Okay, first we'll be drawing the single line diagram, and so you'll be getting clear idea. So what are the equipments they have given is that they have given primary generator, three-phase generator, okay, and followed by three loads. Okay, and followed by three loads, followed by three loads. Okay, and these three loads are motor loads. Okay, so here you can see. So we'll be drawing the diagram, so you'll be getting clear idea. So first we'll be starting from the source side. So it will be your generator, so rated with 100 MVA, comma 33 kV. So the reactance value is 0.15. Okay, and over here we'll be drawing the loads. So these loads are connected in parallel with each other, starting from your motor 1 M1. So it will be around 30 MVA, comma 30 kV, 30 kV with the reactance as 0.2. And for your M2, the power rating alone differs, so it will be around 20 MVA. So here, if the power rating differs, means what it implies means the current drawn value around gets changes, because all the motors are operating at the same voltage, and the per unit impedance is also the same. Okay, so what is the difference between this M1 M2 is that the current flow is different in these motors. Coming to the M3, so it will be around 50 MVA, comma 30 kV, comma 0.2. Okay, so at initial stage we have drawn the source side and we have drawn the load side. Okay, so now you might have got the basic structure of the network. So followed by this, what they have given is that they have given it there are two transformers. So there are two transformers, and can consider this to be a step up transformer. Okay, and after that it is to be followed by the transmission line. Okay, so this one is rated as 32 or 110 kV. Okay, so the rating is 110 MVA, the reactance is 0.8, and for the transmission line it is J50 ohm, followed by, this is a step down transformer, and this will be connected to the load bus. It will be 110 kV, 110 kV bar 32 kV. So the rating is the same, 110 MVA bar 0.8. Okay, so this is the reactance diagram. So this is the reactance diagram, and based upon this reactance diagram we'll be finding the Z per unit for your generator, transformer. Okay, transformer, you can take this transformer 1 T1, and this one you can take transformer 2. Okay, for T1 we'll be finding, T2 we'll be finding, and transmission line also will be finding, followed by your three loads. Okay, so first with the generator, it is ready. So you can just write heading as solution. So over here, just use the same formula what you have used in the previous problems. So it will be Z per unit nu equal to Z per unit given into base MVA nu by base MVA so into base kV given by base kV nu. Okay, the whole square. So this formula you already know. We'll be just directly substituting. So in the problem they have asked to find out they are asked to select the base quantities as generators. Okay, so the common base quantities as generators, and hence is that your base MVA nu and your base kV nu will be the same. Base MVA nu and your base kV nu will be the same. Okay, why in the sense means the question itself they have said that you have to consider your generator rating as the base quantities. So what it will be, Z per unit will be 0.15 into, so our base MVA new is 100, again our base MVA given is also 100 into, then the base voltage rating is 33. Okay, and the new value is also 33. As per the question, this is what you have to consider. Okay, base MVA new is same as the voltage rating. So what you'll be getting, this gets cancelled out, this gets cancelled out, and finally you will be getting Z per unit new equal to 0.15. around the transformer is having the primary to be okay. Students, we'll be seeing this problem in the tomorrow's class. I think still 5 minutes there for you the for the next class. Okay, if possible, you just try for others also. Okay, just try for your motor load. Okay, motor load transformer also. You give it a try based upon the notes what I have given. Based upon the note what I have given. Okay, the 3 points are there, the notes. So based upon the second point and the third point, you just try for your transformer T1 and T2. Okay, you can see. Okay, so it's only 5 minutes for your next class to start. So I'll be signing off today. Okay, so if you're having any doubts, you can just WhatsApp me and you can ask. Okay, so yeah, she having any? So okay, if you're having any doubts, you can just ask. So others can just leave. I'll be there for 5 minutes.
Sir.
Yeah.
சார் ஃபர்ஸ்ட் கேட்டிருந்தேன் சார் அந்த ZM1 வந்து கால்குலேட் பண்ணும்போது J1.0256 வந்தது. அது எப்படி வந்து எஸ் சார்.
இது உங்களுக்கு சால்வ் பண்ணும்போது டேட்டா இல்லையாவா? உங்களுக்கு சால்வ் பண்ணும்போது என்ன
ZM1 கால்சில போடும்போது ZM1க்கு வந்து லாஸ்ட் சம் அந்த 2 ஜெனரேட்டர் ரேட்டட்ல சார். அதுல ZM1 வந்து 1. இதான் சார் 1.0256 இருக்கு. இது அப்படியே எழுதலாமா சார்?
இது வந்து உங்களுக்கு வந்து greater than 1 இருக்கனால உங்களுக்கு क्वेश्चन கேக்குங்களா?
எஸ் சார். இஸ் greater than 1 எப்படி சார் Z வருமா சார்?
அதான்ப்பா, அது வந்து வரும். அது இட் இஸ் பாசிபிள் பிகாஸ் அது நான் ஏற்கனவே சொல்லியிருந்தேன், கிளாஸ் இருக்கும்போது சொல்லியிருந்தேன். இன் சம் எக்ஸெப்ஷனல் கேசஸ் உங்களுக்கு வந்து இசட் வேல்யூ வந்து 1க்கும் மேல போகலாம். ஓகே, பட் ஆனா ஜென்ரலா வந்து பவர் சிஸ்டம் நெட்வொர்க்ல போகாது. ஆனா அப்ப என்ன ஆகும்னா இந்த மோட்டர் வந்து ஓவர்லோடடா இருக்கு. புரியுதா? அதாவது இப்ப வந்து அந்த மோட்டர் ஓவர்லோடா இருக்கிற பட்சத்துல வந்து உங்களுக்கு வந்து 1க்கு மேல போகும். அதான் அது வந்து ஒரு எக்ஸெப்ஷனல் கேஸ்.
ரைட் சார். ஓகே சார்.
நீங்க எடுத்துக்கலாம், 1 எடுத்துக்கலாம்.
எஸ் சார்.
நீங்க இப்ப ஒரு சில இதெல்லாம் பாத்தீங்கன்னா உங்களுக்கு வந்து அதனாலதான் நான் இந்த இது சொன்னேன். டிரான்ஸ்ஃபார்மர் பார்த்தோம்ல, டிரான்ஸ்ஃபார்மர் பார்க்கும்போது நீங்க ரிவைஸ் பண்ணல வச்சுக்கோங்க, பேஸ் கேவியை வந்து நீங்க ரிவைஸ் பண்ணலன்னா உங்களுக்கு வந்து பெர் யூனிட் வேல்யூ வந்து 1க்கு மேல போகும்.
ஓகே சார்.
ஓகே, யூ ஆர் ட்ரைங் டு கெட் அது நீங்க அதனாலதான் இங்க வந்து ரிவைஸ் பேஸ் கேவி வந்து நம்ம உள்ள கொண்டு வரது. இட் இஸ் தேர் ஆர் சம் எக்ஸெப்ஷன்ஸ். ஓகே.
எஸ் சார்.
ஓகே,
thank you.
So can you show the single line diagram once again, sir?
Oh, sure. For the which problem you are saying? For the last
problem? Yes, sir.
Okay, fine. I'll be just posting this in the Google Classroom also. Now itself I'll be posting it up to what we have covered. I'll be posting it. Okay, you can also back refer it.
Okay. Sir.
Yeah.
Sir, I think 2 days before you have said a question, third question, sir.
Yeah. It's just pending. It's pending. I'll be explaining out to these problems and we'll be coming out to that problem. Okay.
Sir, while explaining that, can you explain once again? Can you revise that first and second question also? It's a bit confusing, sir. Difficult.
Okay. Fine. I'll be taking it up. I'll be considering that also. Okay.
Okay,
you just
sir.
follow with this flow. You just follow it, and we'll be again reviewing those problems also again.
No, I'm understanding what you're. I'm understanding, sir, but it's a bit difficult to catch up that, sir. So it will be good when you revise, sir.
Okay, ma'am. Okay, fine. I'll be revising.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.